Vanivilasa Sagara Project Background and History. Written by N. Shankarappa Toranagallu. Read by Inchara N. Progressive princely states were keenly observing the fast pace of development of irrigation in areas which were under direct control of British. Queen Kempananjamani, also called as Vanivilasa Sannidhana, who was ruling as representative of her minor son Nalvadi Krishnaraja Odayar IV, and also Nalvadi Krishnaraja Odayar, after attaining majority, were very eager to take up large irrigation projects in Mysore state. In 1801, a proposal was made to construct a dam across a river called as Vedavati in Chitradurga district and as Hagari in Bellary district, which is tributary of river Tungabhadra. After many discussions, revisions, re-estimates, project was pushed aside without coming to any conclusion. While Hagari was in control of princely Mysore state, Tungabhadra was under British controlled region of Bellary district, which was under Madras presidency. When proposals were made to build a dam across Hagari near Kanive of Chitradurga district, Madras government objected to it as it would deplete the water to Bellary region. Mysore government established its right over Hagari river through many corridors of power and stages. Ultimately, in 1894, the approval was granted to Mysore state to build a dam across Hagari. After technical survey, it was found that the proposed dam site does not have firm river bed to support the load of the dam, and project was once again abandoned. In 1898, K. Sheshadri Iyer, Diwan of Mysore, formed a technical committee under Col McNeill Campbell to study the feasibility of constructing the dam at Kanive. This committee observed that the river bed is laid with hematite, quartzite and schist layers one above the other, and these layers are inclined at 70 degrees to horizontal. It also concluded that the hematite layer, which does not crack under load or dissolve under water, covered most part of the dam site, hence it can sustain the loads of the dam. The core samples of schist layer, which cracks under loading, were tested and its safe bearing capacity was found to be 65 to 80 ton per square meter. The technical committee also observed that due to silting, the cracks in schist layers will be sealed, controlling the leakage of water in due course of time. On these recommendations, the Kanive project was cleared. Initial construction activities were started in August month of the same year, 1898. The construction progressed under three chief engineers, Col McNeill Campbell, Captain A.C. Joller, and Lobinier and C.T. Dalal was the superintending engineer throughout the construction period. Kanive project provides some interesting facts for engineers. It has 5,312 square kilometers catchment area with the average annual rainfall of 596 mm. 970 tanks with total capacity of 6.5 TMC exist on upstream area of Kanive Dam. In 1876 to 1877, during famine, no tank in the catchment area received sufficient water, resulting in death of 1/3 of the population of the area. There was great variation of yield in the catchment area. In 1864, 6.588 TMC. In 1865, 23.652 TMC water flowed through the river. It was estimated that in the heavy rainfall year, the flow would be 32 TMC. Yield under failed rainfall 3 TMC. Normal rainfall 10 TMC. Good rainfall 19 TMC were estimated. On this basis, 20 TMC capacity reservoir was proposed. This capacity is equal to the annual yield of Hagari river. But during cyclonic rains, the probability of reservoir filling full and breaching of a few of 970 tanks upstream of the dam site were also considered, and maximum flood discharge of 1702 cumsecs was fixed for weir design. To enable this discharge, it was required to widen the weir beyond dam length on either side by breaking the hard rock. It was also found that raising the dam height to get required width of the weir is cheaper than breaking the hard planks on either side of the dam. Therefore, the dam of reservoir's capacity 38 TMC was approved for construction. The Kanive Dam, thus designed, has foundation level 8.75 meter below riverbed, level laid on the hard rock with maximum height of 50.935 meter and can retain water in reservoir for 39.65 meter height. At this level, capacity of reservoir is 32.348 TMC. Thus, Kanive Reservoir was designed and constructed for multifold capacity than the available water. As per records, the maximum flood discharge in the river never crossed 1004 cumecs. Even if the design flood of 17 or 2 cumecs flow in the river, this entire quantity does not flow over the weir because at this discharge, the reservoir spreads area increases. The existing weir is 127.5 meter long and can discharge 652.6 cumecs of water. When the depth of flow over weir is 3.05 meter, then the flood discharge would be 1135 cumecs. The sluice which provides water to irrigation canal is 24.4 meters below maximum water level. When the water level above this sluice is 3 meter, the discharge capacity is 29.7 cumecs. Since the water to canal is led through sluices from 24.4 meters level, stony roller gates are provided to this sluice. The capacity of Periyar and Bhatgar reservoirs, which were constructed in Madras and Bombay Presidency, were 6.815 TMC and 4.638 TMC. When compared to the other Indian dams, Kanive Reservoir is capable of storing 2 to 3 times the quantity of available water. In contemporary world of those days, Aswan Reservoir stood first with storage capacity of 38 TMC and Kanive stood in the second place. While Aswan reservoirs filled fully multiple times in each year, Kanive filled to its full capacity only twice in a century, year 1993 and 2000, and now in 2022. Otherwise, the storage is around 25 to 30% of its full capacity. Even though the storage capacity of Kanive is 32.348 TMC, due to positioning of canal sluices, only 8 TMC of water is available for irrigation. With this quantity, only 30,000 acres can be irrigated. If proper canals and methods are implemented, this can be extended up to 45,000 acres. The Kanive Reservoir, which stood second in position in storage capacity, can irrigate only 30,000 acres. This is the success and failure of the project.